Now one question I want you to ask here is, which one will take more time in order for CPU to execute a byte? Okay, let us assume CPU, we are actually calculating the time taken by the CPU to execute a particular byte. Now among these two implementations, which one will take more time? Definitely this will take more time. Why? See, coming to here, what we did, we loaded the base address of a process, fine. Now in the logical address we should have got page number field, fine. Now what we did is we indexed into this process, and then we took the byte and then we executed it, right? So we are actually referring the RAM exactly one time, right? We are actually referring the RAM exactly one time. When are we referring the RAM? We got the base address, we got the page number, we added both, and then we went into a particular byte and then executed it. So while we are going into a particular byte, we referred the RAM exactly one time. But coming to here, we referred the RAM two times. Why? Initially I loaded the base address of page table of P1, fine. After that I got the logical address, fine. Now I will index into the page table. During that time I have referred the RAM one time, fine. Now once I get into the page table and get the frame number, I will replace the page number with frame number in the logical address, and so we got the physical address. Now once we get the physical address, again I will refer the RAM one more time to get the exact byte, right? So here we are actually referring the RAM two times. One time for page table, one time for process. Here I am referring the RAM exactly one time, only for process. Why? Because we don't have page table here itself, right? Now why we are able to get this? Because our process is loaded in contiguous addresses. Here our process is not loaded in contiguous addresses, only our page table is loaded in contiguous addresses, right? So if a particular thing is actually loaded in contiguous addresses, we can apply simple addition on them. Here process is loaded in contiguous addresses, and so we are able to apply simple addition on the process. Here our process is not loaded in contiguous addresses, but our page table is loaded in contiguous addresses, and so we are able to index into the page table using simple addition. But we were not able to index into the page using simple addition because process is not loaded in contiguous addresses. So what you can understand from this is, since this is loaded in contiguous addresses, we are able to go into this page table using simple addition, right? But this takes more time because it needs to refer page table once and process once. See, you might think that these things I am explaining it a lot of times, okay? I am explaining the same concepts over and over. You might feel like that, some people might feel like that, but the actual intention is you need to understand the concept perfectly, okay? That is my main motto. Some people might find it difficult to understand in the initial go, so that is the reason I'm actually telling the intuition behind everything. Why is CPU generating logical address? It is not generating physical address. Why? Because it doesn't know the location in which a process is present. See, these intuitions will make you remember the concepts for a long time, okay? If you simply actually remember it, that it will generate logical address, but if you doesn't know why it is generating logical address instead of physical address, you will keep forgetting it after some time, okay? That is really useless. So the most important point is intuition. Why this is happening? Why we are implementing it like this? That is what you should be spending majority of your time, okay? Fine. So this is what is happening here. This needs two memory accesses. This needs one memory access. Now one important point you need to understand here is, here we are using single level paging. Okay, here we are using single level paging. Why? Because we have one level of page table, which means we have only one page table. Now we referred into the page table. After getting the frame number from the page table, we went into a process and then executed the process. So we had only one level of page table, right? Now in case if I have multiple levels of page tables, we say that as multi-level paging. That is what we are going to see here. Okay, you will be able to understand multi-level paging very well. It is very easy, okay, very straightforward. We will see that.